Hello everyone, welcome to the YouTube channel of NG Core. In this video, we will have a look at the open source project HEXAeBPF. So in the fast evolving world of 5G, deploying and managing your 5G core networks can be complex and time consuming. But what if there is a way to simplify this? So in this video, we will have a look at HEXAeBPF, an open source solution based on Kubernetes operator designed to integrate, manage and deploy open source 5G core networks. So now let us have a look at the HEXAeBPF GitHub page to understand more. The first link here will land you to the HEXAeBPF repository on GitHub. Here you can see we have the HEXAeBPF page with its directory structure. Now let's move towards the README file to understand what HEXAeBPF is. So HEXAeBPF integrates and automates the process of deployment of any control plane, let's say from a vendor A, and an eBPF-based user plane from a vendor B. This means you can get end-to-end 5G core setup in a lab environment with minimal efforts. And this is ideal for telecom researchers, developers, and operators. Now let us move towards the key features. So with HEXAeBPF, interoperability becomes effortless, making the 5G testing, research, and innovation faster. By leveraging eBPF technology, it optimizes user plane performance while maintaining interoperability, flexibility, and security. So why HEXAeBPF is built as a Kubernetes operator? So the managing of 5G core networks can be challenging, requiring precise configuration, scalability, and automation. That's why HEXAeBPF is built as a Kubernetes operator, bringing the powers of automation to 5G core deployments. But what makes a Kubernetes operator the perfect choice for HEXAeBPF? Let's break it down. So with custom resource definitions that we call CRDs, HEXAeBPF enables easy configuration of the control plane and eBPF-based user plane, making deployments intuitive and flexible. From scaling to updates and self-healing, HEXAeBPF automates the lifecycle management, ensuring your 5G core stays resilient and optimized. So the foundation of Kubernetes operator ensures scalability, automation, and ease of deployments within the 5G core. So HEXAeBPF supports a variety of topologies which enable flexibility and scalability in 5G core network deployments. Whether you are using different control planes and user planes or RAN simulators, HEXAeBPF ensures interoperability and automation. Now let us look at the supported topologies. So HEXAeBPF supports multiple control planes including SD Core, Free5GC, Open5GS, and OAI, along with user components such as eUPF, OAI UPF VPF, and E3 UPF, bringing the high performance of eBPF-based user plane functions. Now to complete your 5G lab setup, HEXAeBPF supports RAN simulators such as UERANSIM and OERF simulators for seamless testing and validation of your network architecture. Now let us move towards the GitHub dev environment to have a look on the HEXAeBPF directory structure. So now we are inside the HEXAeBPF repository. The important directory here is the source directory, where we have subdirectories like the CLI. Inside this, we have script related to the HEXAeBPF CLI. And then the other main directory over here is the operators directory, which contain all the HEXAeBPF operator related to control plane and user plane. For example, we have Free5GC eUPF operator over here. Now, if you go inside this, we have control plane and user plane separately. If you go inside the control plane and in config, you will see we have multiple folders. We have RBAC rules, and inside samples, we have this Free5GC v1 hexacp.yaml, which is the configuration file that will be used for deployments of all network functions inside the control plane. So you can see we have multiple configuration parameter for every network function, which is available in the control plane for the Free5GC operator. So just like the control plane, we have the same structure for the user plane also. If you go inside the sample, so this file eUPF v1 hexaup.yaml, we have multiple configuration parameter for user plane component. So now let's move towards the deployment to see how HEXAeBPF works. So for the deployment, we have a fresh VM, and the first step is to simply clone the HEXAeBPF repository. I have already cloned it. So now we'll go inside it. And here let's have a look onto the available files. So we have multiple rollback rules, YAML files, and CRDs available. Now let us move to the deployment part. For this, you have to run this command make run HEXAeBPF, which will set up the case environment. In our case, we are setting our key to clusters, so this will take a while. So now you can see that all the pods are up and running. Now we have the HEXAeBPF CLI, and over here we have the main menu, and here we have multiple options, like we can deploy, undeploy, and along with that we can view logs. So let us move to the deployment part. So here you can see we have a list of available control planes, and we can choose any one of them. For this particular video, we are choosing Free5GC, and now we have the available user plane list, and in this we will be choosing eUPF. And here the available simulator is UERANSIM. So now let us have a look at the deployment details. We have the component selection here. We have the control plane as Free5GC and user plane as eUPF, and our RAN simulator is UERANSIM. So now here you can see the control plane is getting deployed. So this is the Free5GC eUPF control plane operator which is being created. And now you can see the pods related to control plane are also in the init state. So here now you can see that the control plane is up. And similarly, the RAN simulator is now also running. So now we can see that both the user plane and the control plane are up, and now we can exit from this. So now let's have a look at the end-to-end logs. So before that, we will have a look on the CRDs that are available. So here you can see that we will fetch the CRDs. And we have 3 CRDs over here, one for control plane, one for user plane, and one for RAN simulator. Now let's try to get this particular CRD. And here you can see the API kind version along with all the metadata related to the control plane and the CRD. Similarly, we can do this for user plane and the UERANSIM. Now let us have a look at the AMF logs. So here you can see the PDU session has been established for the MC20893. And similarly, we can have a look on the logs of UPF. So we have UPF over here, and here if you look, we have the logs of the UPF network function. And in this particular line, you can see we have the attached XDP program to the N3 interface, which is an eBPF program. Now we can also have a look on the session establishment request with all the parameters related to the PDR rules. So now let us have a look at the gnodeb logs. So you can see ng setup request and response. So ng setup procedure is successful. And similarly for the UV logs, here in the last line you can see the PDU session establishment is successful and the connection is set up for edu session 1, and we have the tunnel interface over here. Now we will exec inside the UE pod and look if the interface is up or not. So we are inside the pod now, and over here we can see the interface is active. So that was all about the deployment process. Now let us clean up the environment. So we will run the same script again, and here you can see we have the option to clean it up. But before cleaning it up, let's look on the logs. So these are the logs of the deployment commands which were used earlier during the deployment process. So you can see we have multiple commands, and all the automated processes are listed out here, which were working behind the scenes for us. So now we will clean up the environment. So first we want to undeploy all the operators. So over here we choose the option number 10. So the process has been started and it will terminate all the pods soon. All the operators are undeployed successfully. So here you can see they are undeployed, and now let's clean up the Kubernetes environment. We have to run this command make clean. Once you run make clean, your VM is clean now. And so with just one click, you deployed the entire control plane, an eBPF based user plane, and the UE Ransom simulator, setting up an end-to-end complete 5G core network with HEXAeBPF. This basically showcases how effortlessly HEXAeBPF enables the deployment, management, and the subsequent teardown of 5G core in the lab and testing environment. This also happens within minutes and with a single command. The future releases will further enhance its capabilities, enabling end-to-end testing with SDRs and commercial radios, expanding its potential beyond testing environments to enterprise adoption as well. So that was all for this video. Thank you so much.